Okay, some more examples. Cosine of 2 theta is equal to 1/2. Okay, so we're still, cosine is in the regions from 0 to 2 pi, but the first thing I want to know, because this theta is not by itself, I want to know, where is the cosine value 1/2? Where is the cosine function equal to 1/2? So go to your unit circle. Whoa. And cosine is the x value. Where's it 1/2? That's at pi over 3 right here, at pi over 3. And okay, I rewrote that a little neater. So pi over 3, and the other one is 5 pi over 3. Okay? Alright, so now we also have to have the multiples of that, right? So let's just say pi over 3. If I went all the way around 2 pi, it puts me back in that same location where the cosine value is 1/2. So we want to account for that as well. So first of all, I'll take 2 theta is equal to pi over 3 plus, we say 2k pi to account for those multiples. All right, that's one of the that we'll have to find. Okay, what's the other one? When 2 theta is equal to our other one, this time we have two values, 5 pi over 3, and we also account for multiple trips around 2 pi. Alright, so now we're going to work on solving this. How do we get theta by ourselves here? Divide everything by 2. Good, so let's divide everything by 2. And that would give us theta is equal to pi over 3 divided by 2. That's the same thing as multiplying by 1/2. That would give us pi 6. The 2's cancel there, so we just get k pi. Now over here, we're going to do the same thing. Let's divide everything by 2. Theta is equal to multiply by 1/2. That would be 5 over 6. 5 pi over 6 plus k pi. Okay, now what we're going to do, just like we did previously, we're going to pick some values for k to plug into this, pick some values for k to plug into this, and find the solutions that are in our 0 to 2 pi and select those as our answers. Okay, let's just, as default, start with k equal to 1. Let's do this first one here. We're going to work on this one first. So theta is equal to pi 6 plus, this time k is -1. And then we just have pi. Okay, so that's just going to give us pi 6 minus pi, that equals -5 pi 6. Okay, let's do 0. So that would be pi 6 plus 0 times pi. We like 0. 0 is one of our favorites. So that just gives us pi 6. So keep doing this for 1 and 2, and then let's check your answers. Okay, so check pi 6, then we got 7 pi 6, and then we got 13 pi 6. Now we're going to do the same thing, but this time I'll do this one in red. We're going to do the same thing with this theta. So I'll do the first one with you. So theta is equal to 5 pi over 6 plus, this time k is going to be -1. And times pi. So 5 pi over 6 minus pi will be -pi 6. Okay, you continue on and finish out the other. Okay, so -pi 6, 5 pi 6, 11 pi 6, 17 pi 6. So we have multiples of k that we're looking at. Now we have to choose the one that are in R, because cosines divide from 0 to 2 pi. We want to choose those values. So let me use a different color. All right, what about this negative value? No, pi over 6? Yes. 7 pi over 6? Yes. This one's easy to see because it's already 2 pi plus something, so we know this one doesn't count. Not only that, 6 goes into 13 more than 2 times plus some left over. What about negative pi over 6? No. 5 pi over 6? Yes. And 11 pi over 6? Yes. What happens? That's 2 pi plus something. Not only that, 6 goes into 17 more than 2 times, so our only solutions, we would list our solutions as pi over 6, 5 pi over 6. If we put them in order, not that you have to, 7 pi over 6 and 11 pi over 6. So all of these values for theta will satisfy this equation. Okay, theta is by itself, so this is back to our, like the very first ones we did. So we're just going to focus on getting this by itself as if this was a variable by itself. So let's add 5 to both sides. Bring down what we have left. Now what? Good. Divide both sides by 10. And we would say sine of theta is equal to 1/2. Now, go to your unit circle and tell me the places where the sine of theta is equal to 1/2. Sine of theta is equal to 1/2 at pi 6, right? And also 5 pi 6. So we'll say pi 6 and also 5 pi 6. Okay, so theta's by itself, it doesn't have a multiple with it, so we're not dealing with the k times 2 pi situation. Let's just solve this thing. Let's add 1 to both sides to get tangent theta by itself. So tangent theta is equal to 1. Now recall, what is the definition of tangent theta? It's the y over the x, or we also can know it as the sine over the cosine value. Sine of theta over cosine theta. Okay, we want to know where it equals that in, where is the sine of theta, the y value over the x value, equal to positive 1? Right here at pi over 4. Not only that, where else? Pi over 4 also, because a negative divided by a negative is a positive, so pi over 4 and also 5 pi over 4. So that's our solution for this one. Alright, 7 secant theta plus 9 equals negative 5. This is one of our basic forms, so let's just solve that. First thing we're going to do is subtract 9. So that would give us 7 secant theta is equal to negative 14. And what would be our next step to get secant theta by itself? Divide both sides by 7. So secant of theta is equal to negative 2. Or what? How else can I see that? Rewrite this. What's equivalent to that? Cosine of theta is equal to the reciprocal of negative 2, which is negative 1/2. Okay, so we want to know where all the cosine theta values are going to be negative 1/2. Okay, where will our x values be negative 1/2? Right here. Here's one of them. 2 pi over 3. So at 2 pi over 3. And is there another one? Yes, good. Right here. 4 pi over 3. So